Let's discuss about loop while. This type of loop is a loop with precondition. It means that the condition of loop is checked before execution of a loop body. The general form of loop while is written here. Maybe it's better to write it in this style. The keyword while, after that some expression, and one computational statement. Body while is a statement that describes a body of loop. Expr, in parentheses, is an expression which participates in checking up the loop termination condition. As far as loop while is a loop with precondition, then the value of the expression is computed before the statement body while. And the result of this expression is compared with zero, with false. Let me remind you that the value zero is considered to be false and not zero is true. Well, if the result of this expression is not zero, then the loop body is executed. But if the result of this expression is zero, then the loop is considered to be completed, and we take the next statement after the loop to proceed the computations. The block diagram that corresponds to loop while exactly corresponds to the loop with precondition. First, the condition is checked. If the value of expression is not zero, then the body of loop is executed. When the body is completed, we go back to the condition and check this condition again. If the value of the expression equals to zero, then the loop is considered to be completed and we continue the program. I will show you some examples. I will show you not here, not in presentation, but in Visual Studio. But before these examples, a few remarks about loop while. As a rule, a conditional statement, conditional expression is used as a loop termination condition. This is the typical case. Next feature. If the loop body is a sequential structure, so if we need to carry out more than one statement in the loop body, this sequence of the statements must be organized as a composed statement. So all their statements must be enclosed in braces. And my advice for you, always use braces to avoid mistakes. Next feature of loop while. Unlike loop for, the initialization of control variable or loop counter must be performed by separate statements before loop while. Moreover, in the loop body, the programmer must write special statements changing the values of control variables. Otherwise, the loop may be endless. Later, I will show you the example of endless loop. Next, the last feature. As far as the expression of loop termination condition is computed before loop border, the loop can be never executed when the first checkup of the expressions gives the result false. In this case, the loop border will be skipped. Okay, let's consider some examples of loop while. First of all, I will write you the example how to output n numbers to the screen. In this case, I will use loop while as a loop with known number of iterations. Let me declare the variable n with the initial value 10. N will be used as number of numbers. After that, let me declare the variable I with initial value 0. I will be considered as a loop counter. After that, I can write the loop while I smaller than n, in the just output to the screen the value of I. Cout I and the space. And after loop, let's output the end of line. So this loop outputs to the screen n numbers in one line using spaces between these numbers. Let's check it. Let's run this loop. And what will we see on the screen now? Oh, we will see 0. 0 a lot of times. 0, 0, 0, 0. What happens? Why? Why we see 0? We see 0 because I forget to write here the statement that changes loop counter. The initial value of I is 0, and I never changed it in the previous version of the program. Now I write here the statement that changes loop counter. And now we will see on the screen the numbers from 0 up to n-1. I can change the value of n here, and we will see not 10, but 20 numbers. I can use any statement that changes loop counter. For example, what happens if I write here I plus equals 2? It means that the loop counter now not increased by 1, but by 2. 0, 2, 4, 6, and so on. And we will see on the screen the numbers 0, 2, 4, 6. If I write here not +2 but +3, we will see the numbers 0, 3, 6, 9, and so on. On previous lesson, I showed you examples of endless loop. If I forget to write the loop termination condition, in this case, not loop termination condition, but the statement that changes the value of the loop counter. in this case, loop will be endless, and we will see a lot of zeros here. 0, 0, 0, a lot of zeros. Moreover, if I write a wrong statement, I smaller than n, and here I minus minus, we will see a lot of negative numbers because I write the rule of changing the loop counter I minus minus, and loop termination condition is I smaller than 20. Negative number always smaller than 20. Yeah, a lot of negative numbers. Okay. Here I can write a complex expression. Let me write this expression: I smaller than n and I greater than minus n. So in this case, we will see negative numbers, but up to minus 20. Let's check it. Yeah. Because I include one more comparison in condition. But this expression is just a logical expression. If the value of this expression is true, the loop will be continued. If the value of this expression is false, the loop will be stopped. And even I can write here these constants, false or true. If I write here true, it means that the loop will be endless. Of course, it's have no practical meaning to write the endless loop, but it will be correct from the point of view of compiler. This program will be correct, and we will see a lot of positive numbers. But if I write here while false, it also will be correct, but this loop will never be executed because this condition is always false. Okay. Well, I show you some examples of loop with precondition while, and now just let me briefly consider loop do while, a loop with post condition. This loop in general form can be written as follows: do the keyword, after that body of loop, and after that the expression. So let me write it in this form: do, then body, and while the loop termination condition. Okay. Here, body is also a statement that describes a body of the loop. And the expression, as in previous case, is an expression that is used as a loop termination condition. If the value of this expression is true, the loop is continued. If the value of the expression is false, the loop is stopped. The block diagram that corresponds to loop do while is presented on the next slide. It differs from the previous case only in a place of condition. Here, the condition is placed after loop body. It means that when we execute this loop at the first time, loop body is executed without checking the condition. And only when the loop body is completed, we check this condition. If this condition is true, we go back to the beginning of the loop body and execute the loop body again. If this condition is true again, we go back to the loop body and execute it. But if this condition is false, then the loop is stopped. And the main difference between loop do while and loop while is as follows. In this case, loop body will be executed at least once, even in the case when condition is false. This is the main difference between these two types of loops. All other remarks are exactly the same. I can say that the expression is a conditional expression, and if we need to carry out several statements in the loop body, these statements must be enclosed in figure braces. Also, we should initialize loop control variable before loop body, and the feature number 4 differs from the feature number 4 of loop while, that the loop do while, in this case, the loop body is executed at least once. Let's check this feature in this simple example. Here, when I write the false condition in loop while, the body of the loop will never be executed. But let's move this while in the end of the loop. And let's write this loop in the form of loop do while. Yeah. In this case, the loop body will be executed at least once. And we will see on the screen just 0. Let's check it. Yeah, we will see it. 0. Any other features of loops are exactly the same. Usually we use the loop with precondition. Maybe it's more preferable for the most cases. Let me write the loop that computes the sum of n numbers. Let me initialize the sum with value 0, and here let me write the expression that changes the value of the sum plus equals I, and after the loop, let's output the value of sum to the screen. Let's run this program and we will see the value 190 as a value of sum of all the numbers from 0 to 19. If I write here another comparison operation, not less than, but less than or equals, in this case, we will see the result 210. Well, and the next example that I want to show you is the example where loop while is used as a loop with unknown number of iterations. Because here, in these two examples that I showed you, the loop while is used in the form of loop with known number of iterations. We know in advance that the loop must be repeated 20 times. But let's consider the following problem. Again, this problem this problem was described in my video that I sent it to you on previous lesson, but let me repeat it online now. Let's try to compute this sum that equals to the sum of the following sequence: 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5 plus, and so on. Let me denote this sum as x. So the value of x equals to 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, and so on. And let's write the first version of this program. The first version, let's compute the sum of the n numbers organized in the following in this way. So the loop counter, in this case, I should start from 1. And the value of the sum, it must be double. Double or a float, it doesn't matter, but it's better to use double because double have the type double have twice more precision to represents the real numbers twice more precisely in comparison with the type float. Well, double x equals to 0. And let's write here the expression that x equals to 1 over I. X plus equals 1 over I. And I is smaller than n, smaller or equals. Let's compile this program, or of course, here I should use not sum but x. Let's output this x to the screen. Okay. Well, can you guess what we will see on the screen if I run this program? For example, let me write n equals 2. Just two elements of this series. What we will see on the screen? This question is not so simple because we will see on the screen. Two. Oh, sorry, one. Of course, we will see one. not 1.5, but 1. We will see 1. Why? Let me remind you that when we write the division operation, and if both arguments of these operations are integer numbers, in this case, this division is integer division, and the result of this operation is the integer part of the result. And when we divide 1 over 2, the integer part of the result is 0. I can take not 2 but 20 numbers. The result will be 0 again. Sorry, not 0, 1. The result will be 1. 1 plus 0 plus 0 plus 0. We should stress that this operation is a float operation, operations with real numbers. To indicate it, I must write here not 1, but 1.0. 1.0. And in this case, we will see the real result. Let's run this program for 2, and we will see 1.5, the real result. If I run it for 20 numbers, I will see some other value. Well, but now, suppose that I compute this sum for very, very long series, 1 over n. It's a very impressive fact from the mathematics that the value of x can be very large. Even the elements of this series is smaller, and smaller. The total sum can be very large. And the question can be as follows. What will be the number n? What will be the number of elements of this sequence to have the x greater than some given number, some x given? So we have some given number, x given, and how many elements we should summarize to get x greater than x given? I don't know. And nobody knows. We should summarize these numbers and we should interrupt the loop when the x will be greater than x given. And in this case, loop while will be the loop with unknown number of iterations. Well, let's introduce here a new value, x given. And let's consider the first example, just 2. And the question is, what will be the value of I that gives us the value of x greater than x given? So the loop should be repeated until x smaller or equals than x given. The condition of loop is changed. This loop will be repeated when x is smaller than x given. And instead of x, let's output to the screen also the value of I. And this value, the value of I, will correspond to the last element, to the last number, 1 over I. Let's output also not only I, but 1 over I to 1.0 over I. Well, let's run this example with x given equals 2. What will we see on the screen? We will see on the screen that it's enough to add, it's enough to summarize 5 numbers. The last value of sum will be 2.08333, and the value of 1 over I equals 0.2. So 5 elements of this sum, it's enough. 1, 2, 3, 4, 5 to get the final result greater than 2. Okay, let's input here 3. 12 elements. And the last value of x is 3.01988. Okay, let's input 5. 84 elements. Very good. Let's input 6. 224, 28. And the last element of this sequence, 1 over I, equals to 0.004. And so even I increase this sum on 1 over 10, the number of elements will be increased dramatically. For example, let's input 8. Yeah, 1,000 elements. More than 1,000 elements must be summarized. And so on. It's a very impressive example. In theory, theoretically, I can input here any number, 20, 50, 100, 1,000, but computer can summarize this very, very long sequence to get their final result. But this loop, in this case, is completely a loop with unknown number of iterations, because nobody knows how many iterations is required to satisfy this condition. Well, that's all that I want to say briefly, very, very briefly, for about loops with precondition and postcondition, and about loops with unknown number of iterations. After the lesson, I will send you the video file of this lesson. You can watch this video again. You can write these examples on your computers and on your Visual Studio. You can modify these examples to better understand how it works. Well, now let me stop sharing the screen. And let me stop